ladies and gentlemen, this is Capandball here, your favorite gun channel in beautiful, bright English language, and today I'm continuing the series about the handgunners, the earliest firearms, the hand cannons. I was very excited when I was filming the first chapter for you that is describing the concept of how to make a single-shot muzzleloader into a repeating muzzleloader the 15th century way, and I'm just as excited to show you the results of the second part. I received quite a few good ideas on our social media platforms about how to make this concept work, well, with a modern time of thinking. Well, I'm pretty sure that with our modern knowledge and modern science we can solve this problem and we can make this into a Roman candle. But what I'm really excited about is how the 15th century and 16th century sources work. So I will still stick with them in this chapter as well. If you saw the first chapter, then you know that I was able to make it a two-shot repeater. I placed the charge with a well-sealed bullet, as we usually do, in the breech of the barrel, and above that a powder charge with a pierce-through bullet. Now, on top of the pierce-through bullet, I poured some powder and I ignited that powder from the direction of the muzzle. If I fired this first shot, then I still had the second shot in the breech of the gun that could be ignited from the touch hole, which means it was a two-shot repeater. But I was not able to make it a Roman candle, which means that if I placed other charges on top of the traditional charge, like powder, pierce-through ball, powder, pierce-through ball, I was not able to achieve a delay between the shots that were ignited from the direction of the muzzle. Now, this chapter is dealing with this problem. But before we continue, let me ask for your support. Being an educational gun channel on YouTube is not easy. The algorithm is not my friend, that's for sure. So your support on patreon.com/capandball is vital for keeping the quality of the channel high. On Patreon, you will also receive exclusive content from me. We are also present on the History of Weapons and War platform. That's an excellent hiding place for gun nuts like us. Here you will be able to watch all our content ad-free. So if you subscribe, it is very comfortable for you. Please subscribe, like, share, and comment, because that will help the channel grow. Because as I told you, the algorithm will not help me grow. So thank you very much, guys. While I was evaluating the results of the previous chapter, thinking about why I was not able to achieve a delay between the shots, I came up with two solutions, two problems I caused during the first shooting tests. First one was the powder I used. In the 15th century, corned and pulverized powder were existing parallel. They were both used for handgunners and they were both used for cannons. Well, for cannons, the meal powders, the pulverized powders were used more often. Now, a meal powder that we sometimes call serpentine powder is a very fine powder. Its ignition is harder, it burns slower, and it delivers less energy. But before we continue, let me suggest you a read. Please visit the webpage of the University of Leeds. They had a medieval gunpowder research group that conducted a beautiful experimental archaeology project with recreating medieval gunpowders based on the manuscripts. So they followed all the little details that were accessible there. So they posted the results of these tests on their webpage. There are 15 reports, if I remember right. They are freely accessible with millions of little information about the medieval gunpowder and their usage. So read it, it's value, it is pure value. I added the link to this little portal in the description of this video. Let's talk about black powder. Not about its history, but about its physical and chemical characteristics. First of all, this is not a chemical compound. This is the mix of the three ingredients: sulfur, saltpeter, and charcoal.
The most important fuel of the burning is the charcoal. The saltpeter is a strong oxidizer to speed up the burning. Sulfur helps the mix to ignite and contributes to generating gases.
Let's start with the ingredients, where charcoal is burned in a charcoal pile. The charcoal pile is ignited and the burning evaporates the water and all the volatile components of the wood. What remains is the charcoal. It is crushed and pulverized, and that is what we need for black powder making. The second ingredient is sulfur. Well, sulfur is accessible in nature. It can be mined. The raw sulfur, that must be refined. The refining is done with evaporating it. In a second vessel, it is turned to liquid again, and at around 110 Celsius temperature, it is poured into molds and allowed to cool. The third and probably the most important ingredient was the saltpeter. Well, saltpeter that is accessible in nature as well. You can find it in cellars, you can find it in caves, but not in a quantity that is sufficient for making large quantities of black powder, so it had to be manufactured. Well, it was grown on saltpeter beds. It was collected and then refined with a very complicated and time-consuming process. So for a long time, this was the bottleneck of black powder making. According to the categorization of the medieval gunpowder research group of the University of Leeds, the following types of black powder were existing in the medieval times. The procedure started with grinding the ingredients into powder state and then mixing them according to the ratios that were suggested by the manuscripts. If the procedure stopped here, it is called the rough powder. If a finer quality powder was to be achieved, then this mix was dampened with water or with other liquids. Little balls were formed. These balls were dried, they were then crushed, they were then grinded into powder state again, and this is called the meal powder. If these balls were not grinded into powder state again, but they were crushed, and the different corn sizes were separated by sheaves, it is called the granulated or the corn powder. Although our black powders today are granulated powders, they are much stronger than the original medieval powders because they are much denser. Because at two certain points of the production of the modern powders today, they are compressed. First of all, the incorporating mill, which is today a roller mill, that is incorporating the particles much better. So they are pushing the sulfur, the saltpeter, and the charcoal particles together with a much stronger force than what they used in the medieval times. Second, when these cakes are formed, or these balls are formed, they are also compressed now. So which means that the density of today's modern powder is around 1 gram per cubic centimeter, and I'm pretty sure that the medieval powders do not reach half of this. And it is not just the density that makes the difference between the force of the modern powder and the medieval powder, but also the ratio of the saltpeter in the mix. The medieval powders saltpeter ratio is around 50 to 70% in most cases, while the modern powders are usually at around 75%, which means that they are much stronger. The more the oxidizer you have in the system, the faster it will burn.
Here are some of the earliest European black powder recipes we know about. Very few of them reaches the 75% saltpeter content.
So I definitely needed some meal powder for my experiments, and I was very happy to get some from a friend of mine. Now this powder still contains 75% of saltpeter, which means it is a bit stronger than the original medieval powders for sure, but at least it's pulverized state. It is taken out from the production procedure just after incorporation, before the corning, so it will, well, suit my needs. Of course, it would be nice if I could make my own black powder, but in Hungary I cannot do that right now, so I will have to stick this one. But it's quite good. Using meal powder for black powder shooting is quite tricky. It can be quite challenging in damp weather because it's hygroscopic, which means that it captures the humidity from the air, rendering it sometimes completely useless. So you are going to have some misfires. I had some misfires because of this as well on a rainy day. Second, when you're charging your ball, you're ramming down your ball, you have to be very careful because the powder is so fine that you can easily push it out through the touch hole. So the touch hole must be covered as you are pushing down your bullet. Okay, so this is day 2, ladies and gentlemen. The first shot will be fired using serpentine powder. It's in. The projectile will be a slug. Oh, it blows out on the touch hole, which is not really healthy.
Here I was hoping that I still have some powder in the chamber, but I was completely wrong.
Meal powder is very sensitive to compression, which means that if you ram your bullet down too hard on the powder, you are going to reduce its force drastically. If you check the original manuscripts, in some of them you can find the loading procedure where you have to leave some air gap between the powder and the projectile. Now this is something that we don't do today, but probably this is the cause why this was suggested by the original manuals. But we'll have to cover the touch hole because otherwise The powder will be pushed out through the touch hole. It is so fine. Okay, it's down. Not the strongest shot on earth, that's for sure. Of course, the residue of the meal powder is much thicker than in case of the corn powder. So which means that after a few shots, it will be really hard to ram down your bullet, if it's a tight-fitting bullet, of course. So be prepared that you will have to clean your bore or limit your shooting to 3-4 shots. Fifth is a logistics problem. So due to the different specific gravities of the ingredients, they can separate on long roads when they are traveled. They are transported in kegs, powder kegs, and if they're shaken for a long time, these ingredients will separate, meaning that the sulfur will be on the bottom of the barrel, and on top there will be the charcoal, leaving different quality of powder on top of the keg than in the bottom, which is not good for the artillery, for sure. This is why we have so many sources that state that the black powder was delivered to the exact usage in ingredient form. It was much safer also, by the way, if the Chinese snow, the saltpeter was separated from the other ingredients. Actually, when shooting my handgun with serpentine powder and meal powder, I encountered all the first four of this. Of course, I did not have any kind of problem with the transportation because I was not transporting that powder for a long time. But all the 4 came out while I was using the handgun. But there are also some advantages in using meal powder for handguns. They burn slower, which allows us time for aiming. If you check the images of original manuscripts, you can see 2 kinds of holds for the handgun. The first one is holding it in the armpit and igniting the powder, the priming powder, through the touch hole with the other hand. And the second one is putting it on the shoulder and aiming it with the traditional way as we do it today. This is much better for accuracy, by the way. So, and this kind of hold is allowed because of the slow burning of the serpentine powder or meal powder in the touch hole, which gives you 1, 2, 3, 4 seconds until it will fire. Alexander Spiridonov already proved this in a series of videos. They are quite interesting to watch because you actually have the time to put that handgun on your shoulder for better aiming. There were at least 3 methods for igniting the powder charge in the handgun. The first was using meal powder inserted into the touch hole and then igniting it with a slow burning match held in a match holder. The second method was inserting cherry red hot metal wire into the touch hole. And the third method was just putting ember on the priming powder on the touch hole. Now the second question that arose when I was evaluating these results is that probably my projectiles, my pierce-through projectiles are not sealing well, which means that the ignition happened not just through the touch hole, but all around the circumference of the bullet as well. For me, they seem to be tight-fitting projectiles because they were very hard to ram down after the second or third shot. But in fact, there could be probably gaps that led the flashes from the first charge directly into the second charge and causing a simultaneous ignition. So I decided to improve the seal of the bullets by adding a thin layer of paper on the bottom of them. So probably this will eliminate these small gaps that allowed the simultaneous ignition. So I believe that the simultaneous discharge was caused by the too fast ignition in the touch hole of the bullet. So this is something that I would like to slow down to have delay between the frontal ignited shots. Well, I have an idea for that. I'm going to moisten some powder with good old-fashioned palinka, and apologies to God for using palinka for such a purpose, but there is 50% alcohol in this, which means it is perfect for moistening the powder. And I'm going to put that paste and let it dry in the cavity, and probably this will slow down the ignition so we can have delay between the shots. Well, we will see. Let me show you how I do it.
At this point, you should be watching the process of preparing the slugs for the experimental archaeology project, but due to YouTube's content policies, this cannot be shown here. However, this part is visible in the full version of the video, accessible on our Patreon page. Just follow the link on the card or in the description. Let's do a little experiment with the serpentine powder charged slugs, just to see the concept outside the barrel. Let's slow this down as well. Now this is so far so good, but I'm really curious whether this works in the barrel as well. At this stage, the patch roundbore charge is already loaded in my bore.
But now I'm going to charge a slug that has the 103F powder as a mass added to the cavity. I will also add some more seal around the projectile, so it is wrapped in paper. In the center it is punctured to help the flames go through perfectly.
Please note that this loading method is not considered safe according to today's standards, therefore I do not suggest you to repeat it. I'm doing this for the sake of science with additional safety measures, like not holding the gun in hand and remotely firing it while I'm protected in a cover.
Okay. Let's give it one more from the same. Also the paper.
The ignition of the bullet, made with the paste from granulated powder, failed. Let's try the one that was prepared with the paste of the meal powder.
Unfortunately, this idea does not work at all. So when you put that mass into the cavity, it does not ignite. Okay, I will neutralize the charges with water and then remove them. The serpentine powder gave a very nice and slow ignition. I already have the powder and the patch roundbore of the first charge, the traditional charge, loaded into the breech. Now we are going to charge the gun with serpentine powder. 2 superimposed loads. Very sticky powder. I'm also going to wrap the bullet into a thin layer of paper.
But before that I compress some meal powder into the cavity.
Of course, I'm going to piece the paper. So we won't have any obstruction in front of the touch hole. Now comes the second charge. Let's shake it a bit to help it into the cavity. Probably this will help. And then the second charge. Charge the same method, using the same method. Let's puncture the hole. Okay. Let's run it down. It's down. And let's give it some more powder on top to help the ignition. I'm gonna shake it a bit also, just to help it into the cavity. I really hope it will work out. Let's try it. Well, that was definitely 2 shots. The first one was very weak. I don't know why, but it was very, very weak. But the second was quite good. It was quite good. Let's see if we have the surcharge in the bore. Oh yeah, we have it. So first we fire it, and then we reload again. Well, I don't know where the first shot went, but it's definitely not on the target. But the other 2 are quite good. We are moving forward step by step. This was definitely 2 repeating shots, charged from the front with delay. And we had the third shot, of course. Now let's try this once more. So there's the bullet hole of the last shot, probably 2 shots. I'm not 100% sure about it because it seems a bit oval. It seems a bit oval, a bit bigger than that one. So actually this was a simultaneous blast, which means that 2 charges went off simultaneously. And there is one big hole in the target, which tells me that the 2 projectiles just went through the same hole, which is quite accurate at 10 meters, which is good. But in fact there was no delay between the shots, which means that we did not reach the original goal. So what do we learn from today's experiments? Well, first of all, I was able to make a Roman candle. At least once I was able to fire the gun that I was expecting it to fire, which is good, which it makes me really happy. So this is when experimental archaeology plays an important part in understanding old firearms and old tactics, by the way. But in fact, I was not able to repeat it. Until I cannot repeat it, it cannot be considered a scientific result. So it must be repeatable. So I still have to work on this. I also learned that using the meal powder is much more difficult than using corn powders. I never ever pulled as many projectiles in my life before than on this day. So, which means that I will have to still experiment with the meal powder to understand better how it must be loaded, how it can be loaded properly. I'm also thinking about changing the projectile. Well, the original method does not seem to work, but I have to improve the seal of the projectile. I cannot improve it with increasing the diameter of the projectile because it will be very, very hard to ram down. Even it will be impossible to ram down, which is not good. So what I'm thinking about is patching the projectiles. So patches were used in the end of the 15th century, beginning of the 16th century. We have sources for that. So which means that I'm going to manufacture smaller diameter pierce-through slugs, and they will be patched with closed patch. Probably this will improve the seal, so the ignition can only happen through the touch hole, and probably this will eliminate the simultaneous discharges.
The image you see here is from Martin Leffelholz's military codex. In the center you can see patches cut from leather. And there's a little box for grease. And there is also a tool for punching the round patches.
Okay, let's start the fun again. Today's first charge will be 1 patch round ball and 2 patched pierce-through projectiles. Now these projectiles, well, the cavity will be filled with fine serpentine powder or meal powder. And we will see what happens, if we can get a delay or not. Now the difference compared to the last time experiments is that I'm going to use a patch to have a proper seal around the slugs as well. The slugs are now undersized with 0.5 millimeter, and I'm going to fill that gap with this greased patch. You can see that it's punctured in the center, so for the touch hole we have the space there. Let's check it. So we will start with the first powder charge. There comes a patch. The round ball. Push that down with covering the touch hole so we don't push out the powder. It's firmly in place. Second powder charge. Okay, let's prepare the slugs.
The touch hole on the slug is filled with powder again.
Now we carefully wrap it in a patch, so to have the touch hole in the center. And I'm going to push it down gently. Okay. Now comes the second charge. I'm going to compress it or tap it. It's not a compression, just to tap it. Probably have to have a better ignition. And on top we put the same pierce-through slug. With filling the touch hole with powder. We compress it a bit. There comes the patch again. So we push down the charge gently again. Okay, that should be good. And we put some powder on top to help ignition.
Let's check this in slow motion again.
Yes, ladies and gentlemen, that was definitely 2 shots with the same force. Yes, 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 yes. Let's check if we have still that original charge there. And we have it there. We've got the Roman candle concept here. Let's fire the last shot. And it is accurate also. 1, 2, 3 shots are, let's say, within 9 centimeters, which is good, The concept is working. So after so many failures, I'm getting there, ladies and gentlemen. It seems like the problem was the seal around the slug. So if you have some gaps around the slugs, even if you don't know it because it seems so tight-fitting that you can very strongly hammer it down on the powder, there can still be gaps. And if there are gaps, it means that the ignition does not happen through the touch hole, but all around the circumference of the slug. If you eliminate that, you're there.
And this is the same loading method to check if the result is repeatable. It was faster, but there was a delay. Let's check it in slow motion.
So I could convince my handgun to fire at least 3 times the Roman candle, which is quite good. But I still think that there are serious issues with the concept described in the manuscripts. First, it seems to work only with meal powders, pulverized powders, not with granulated powders. Second, if the touch hole is not filled completely with powder, then the charges can go off simultaneously. Third, if the seal of the projectile is not good on the circumference, then the flashes can go through there as well, which means that it will cause a simultaneous discharge also. And I strongly doubt that this could be achieved with the cylindrical projectiles displayed in the manuscripts. The patches I used for sealing the projectiles did exist in the 15th and 16th century, but it is not mentioned in the manuscripts displaying or mentioning this kind of loading method, which means that it is my addition only. Fourth, I had misfires when the first charge ignited, but the second one failed to go off. Well, in this case, if it happens in combat situation, it will mean that you will have to fire your gun through the touch hole to get rid of the charge there. And then you have a powder charge, a projectile, powder charge and projectile, which means that if you have a weak material that was used in the medieval times for making gun barrels, then your barrel can burst, which is not healthy. Fifth, you cannot control the delay between the shots. It's not like a machine gun, because you will never know how fast it will actually fire. If you have powder in the cavity, in the small hole in the center of the bullet, it will be slower. If you have an air gap there, it will be faster. So my assumption is that the theory can work, we proved it, but all these changing factors render it unreliable for combat use. So all in all, this concept does not seem practical to me. But it is very, very interesting, and I really hope that you enjoyed it as much as I enjoyed making the film for you. Ladies and gentlemen, thanks for watching. You've been watching the Capandball YouTube channel. If you like what I do, then please subscribe, like, share, comment this video. Please support us on patreon.com/capandball. Here you will find exclusive content from me, and visit us on History of Weapons and War platform. So ladies and gentlemen, until next time, stay cool and keep your powder dry.
Good days indeed. Probably this was something that nobody did in the past 500 years.